Okay, Assalamualaikum. My name is Muhammad Adil Aiman and my matrix numbers is CE220106, and today I will do my part, which is question 1 for my group. And okay, for question 1A is identify the following first order differential equation. So for the first A1 is t dx over dt equal to 3t2 minus x power of 2 t minus 2x. Okay, this question we must simplify just dx over dt, so which is t we must put in the back. Okay, it will become multiply 1 per t, so it will get this answer. So this answer is fxt. So this question we try use homogeneous method to get to identify the first order differential equation. So fxt we must include xt with lambda, so it will come here, and also the question will become like this, and then we must separate lambda from the question, and it will become lambda power of 2, and this also power of 2. Okay, we must cancel out the lambda, and this is the answer. Okay, the answer is just like the question, so which mean uh, f fxt is can be solved in homogeneous equation with degree of 2. Okay, for question 2 is not question okay, for A2 Roman is dy over dx equal to 1 minus 2y minus x over 4y plus 2x. This question we can use the variable separable, which is first we must spread this 4y plus 2x to 2 bracket 2y plus x, and then this question we can see it is t, which is uh, x is 1, so it got 2 dy over dx plus 1, so it is dt per dx. So dy per dx is 1 over 2 bracket dt over dx minus 1, and then and then 1 over 2 bracket dt per dx minus 1 equal to 1 minus t over 2t. So this method is convertible to variable separable. Okay, for the part B of the simulation, the first line of code define the function y(x) and that as a symbolic variable. Next, the second line, take derivative of function y(x) and store in the variable of dy. Okay, in the third line, a differential equation is defined as 2 star y power of 2 plus x power of 2 per y star x equal to dy and store in the variable of ODE. And the next line, display text differential equation followed by actual differential equation in store in ODE. The next line, display the text solution followed by a differential equation diff y(x) plus exponent x plus 2 star y(x) equal to 0. Okay, for the next line, the initial condition differential equation y2 equal to -1 and store in the variable of con. So the next line, function dissolve is used to solve the differential equation defined in ODE. And the condition specified is COND. So the solution is stored in the variable of sol. Finally, the last line, simplify, and the solution stored in sol and display it. So this is the calculation that has generated from the coding, and it get the answer from same as the manual calculation. Okay. For the question C1 Roman, uh, the coding at the first line define the function of yx as a symbolic variable. The second line takes the derivative of yx and stores it in the variable of dy. And so the third line define the differential equation as diff yx plus 2y equal to exponent x and stored in the variable ODE. The question then display on the screen. Okay, the next line, define variable of p, q, a, b, I, m, and y. These variables are intermediate step in finding the general solution to the differential equation using the integrating factor method. The display command is used to the text differential equation followed by the differential equation stored in the ODE. Okay, the function dissolve is used to find the general solution to the differential equation defined in ODE. The solution is stored in the variable of y sol. Okay, finally, the the text display on the screen with the text question solution followed by the solution stored in y sol. So this is the calculation that generated from the coding, and the answer uh, same as the manual calculation. Okay. For the coding for question C2 Roman is the first line define the function of yt and as the symbolic variable. So the second line take the derivative of yt and store in it in the variable dy. Okay, the third line define the differential equation as diff y plus 1 I star sin t equal to sin t. So initial condition is y p I equal to exponent 1. So the solution to the differential equation is found using the solve function, and the result is stored in y sol. Okay. The next, the display command is used to display the text differential equation followed by the differential equation stored in ODE. Okay. The dissolve function is used again to find the general solution to the differential equation. So the result is stored in y sol. The solution stored in y sol is simplified using the simplify function and stored in y sol. Finally, the solution is displayed on the screen with the stack solution followed by stored in y sol. So did our group have get for the coding, and then it generated to this answer. Okay, for this answer, it has the same answer as the manual calculation.
Okay, so here is the MATLAB simulation for question number 2, which is the simulation is to determine coefficient and find the general solution. So here is the answer, which is x multiplied by exponent to the power of 2x plus exponent to the power of 2x plus exponent to the power of negative 5x. Okay, so I'm going to explain about the simulation that I'm using. So the first one is the define the differential equation. Alright, so for this one is um, this one is a symbolic function. It's defined using the SYM function. Okay, so the first derivative of yx with respect to x is represented by dy, this one, and the second derivative of yx with respect to x is represented by d to y. Okay, this one. The differential equation of y plus 3y negative 10y equal to exponent to the power of 2x is defined as the simple equation of eqn. Alright, so we move to the next one, which is on the line 7 and 8. Okay, so this is the particular solution, which is g is guessed as x multiplied by exponent to the power of 2x. This is using the method of undetermined coefficient. Okay, so we move to the next one. The next one is on the line 10, 11, and 12. So the first and second derivative of gas G on the line 8 with respect to x are found using the differentiate function. So these two. Alright. So for the next one is on the line 14. The gas is substituted back to the original equation to see if it works. The simplify function is used to simplify the expression. If the result of this line is equal to 0, then the gas works. So here is the simplified. Alright. So for the next one is on the line 21. Okay, so on the line 21, this is the homogeneous solution, which is y underscore h is found using the dissolve function, which solve the homogeneous differential equation y plus 3y negative minus 10y equal to 0. So the general solution y is found by adding the homogeneous solution yh, this one, and the particular solution g, and the result is displayed by using the display function. So this one is the display function. If I click the run section, then this is the answer that we got. Alright. Okay, so this is the second method simulation. Finding the general solution using the variation parameter. So I'm using this one simulation. So I'm gonna explain it. So for the first one is SYMS, which is this line declare the symbolic function yx as a symbolic variable. For the third line is dy equal to differentiate yx. So this line calculate the first derivative of yx with respect to x and store it in the symbolic variable of dy. So for the next one is this line calculate the second derivative of yx with respect to x and store it in the symbolic variable of d to y. So for the fifth line is this line defines the non-homogeneous equation, which is y plus 3y minus 10y equal to exponent to the power of 2x. Okay, so using the symbolic function, symbolic variable, which is d to y, dy, and y, so it store it in the symbolic variable of eqn. So for the next one is y solve x. This one solve the equation eqn for yx and store the solution in the symbolic variable of y solve x. And for the last one is display. So this line is just a display solution, which is after calculate all the variable, it will display in the common window, which is here. So this is the answer, which is same as the manual calculation. So that's all. Thank you.
So for this line, the line A is equal to negative 10 and 10 this is the metric defined 2 times 2 matrix A, and the line EIGA, we calculate the eigenvalue of matrix A using the EIG function. So the eigenvalue are a scalar that correspond to the roots of the characteristic equation of the matrix. So for this line, this code define a 2 times 2 matrix A, calculate its eigenvalue of an eigenvector and update the matrix. So the line A is defined 2 times 2 matrix A. The line EIGA calculate the eigenvalue of matrix A using the EIG function. So this line, we are just change 0.44. That is, we get the 0.44, and then we get from the manual calculation 0.44. The difference is between 0.44 and negative 3.03. So we are calculate the eigenvalue and eigenvector of the matrix A using the EIG function. The eigenvector are stored in the matrix B, and the eigenvalue are stored in the diagonal matrix L. Today I would like to explain about simulation for question 3. So this is the MATLAB code for solving ODE question for question 3. So the line 1 SYMS Y1T Y2T declare two symbolic function Y1T and Y2T, and for the line A define 2 times 2 matrix A, and for the line G, this one line G, define 2 times 1 for the matrix G, and for the line Y, Y1, Y2 define 2 times 1 column matrix Y made up of Y1T and Y2T. For this line, uh, for this line, differentiate Y equal to A times Y plus G. Define the ODE where different Y represent the derivative of Y with respect to time. T means respect to time. For the line for this line, Y1 use DSO function to find the analytical solution of the ODE. So the line one Y1 solve T is equal to simplify Y1 solve T, and Y2 solve T is equal to simplify Y2 solve T. Simplify the solution obtained in the previous step. So the line C is equal to Y to 0, and define the initial condition for the ODE, and the line Y1 solve T, Y2 solve T is equal to we use the dissolve function to find the analytical solution of the ODE with the specific initial condition, and the line display Y1T solution, and display Y2T solution, display the solution for Y1T and Y2T respectively.
Alright, my name is Amir Amri Razik bin Azmil. So my metric number is CE220002. I want to show you how to use a MATLAB for the question 4. So firstly, we need to use SYMS space T space S. That means is symbolic for this question. So the next line, we need to insert the equation x equal 2 times exponent power of negative 3 times t, then times sin power of 4 times t. Okay, then for the next line, we find the f. That means is Laplace. So how to find Laplace in this question? We need to use f equal to Laplace. So I get the answer for the Laplace is 8 over s minus 3 power of 2 plus 16. This is for the Laplace. Then for the answer for this question, I use a simplify. Then f for the Laplace. So the last answer I have is 8 over s minus 3 power of 2 plus 16 for the Laplace answer. Then for this question, I use pretty in bracket answer to I get the final answer of this equation. So the final answer is 8 over 2 times s minus 3 plus 16. Alright, next I show you about the coding if from this question. If we don't put the semicolon, so if we enter for the x, this coding show you again about the equation, so we don't need to this answer. So again, if we don't put the semicolon also, then we put the semicolon, then we put the f equal Laplace x. The coding will be shown for the Laplace, like first full coding. The answer for the Laplace is 8 over s plus 3 power of 2 plus 16. So from this coding, we need to put the semicolon to find the f is equal to Laplace. If we don't put the semicolon, the coding is repeated about this question. Alright, next I will show you about the question of 4a to Roman. I still use SYMS space T space S. SYMS space T space S. Then I insert the formula x equal 3 times exponent power of negative 3t times Heaviside. That's mean in formula is h t minus 2 semicolon. Then find the Laplace. F equal Laplace x. So from this coding, I get the Laplace answer is 3 times exponent power of negative 2 times s times exponent negative 6 over s plus 3. Then from this Laplace equation, I simplify this equation. So I put the simplify f. So that means this coding is simplify the Laplace equation. So the answer is 3 times exponent negative 2 times s minus 6 over s plus 3. Then from this simplify of the Laplace, the final answer I need is pretty in bracket answer. So the final answer is exponent negative 2 s minus 6 times 3 over s plus 3. That's all. Alright, next I show you about this error of this coding. If I didn't put the SYMS space T space S, I directly put the equation. I use the same equation, x equal to 3 times exponent power of negative 3t. Then for the heavy side, I didn't put the full words of the heavy side, and I just only put the h times t minus 2, then semicolon. Then if I didn't declare about the h, that's mean of a heavy side, so the equation cannot be read an error. So go back for the real coding. We must put a heavy side. That means the formula given is h times 2t minus 2. Semicolon. So we can go for the next line to find what we need, such as f equal Laplace. So we declare about the h and with the heavy side. So we want to find the f equal to Laplace. The coding can be read and give the answer. Okay, next for the MATLAB solution in question 4b, I use a same instruction. That means is SYMS space T space S. So the given is R equal to 4 semicolon, L equal to 0.5 semicolon, C equal to 0.1 semicolon, and E equal to 10/h. So for the equation, x equal to open bracket E times open bracket S slash L times S power of 2 plus R times S plus open bracket 1/c close bracket. I use a 3 close bracket because from the first equation I open the bracket with a 3 open bracket. Then lastly I close with a 3 close bracket. then semicolon. So for the next row, find, I use f equal for the inverse Laplace transform. So I, that's mean inverse, then I put Laplace x. This coding show the answer of the inverse Laplace transform. The answer is 10 times sin 2t times exponent power of 4t, negative 4t. So I simplify for the inverse Laplace transform answer. Simplify f. So I get the answer is 10 sin power of 2t exponent negative 4t. Then I use a pretty answer. I get the final answer is sin 2t exponent negative 4t times 10.